Hello, this is Miss Moore, and today during chemistry we're going to discuss the applications of the ideal gas law. Specifically, we're going to learn how to calculate density and molar mass. Today's essential question: how can density and molar mass be calculated using the ideal gas law? Before you proceed with this lecture, make sure you have available both your calculators and your handouts. Molar volume of a gas at STP, or standard temperature and pressure. And what is standard temperature again? 0 degrees Celsius, or 273.15 K, and standard pressure is 1 atm. Molar volume. The definition of molar volume is the volume occupied by 1 mole of any substance. So right now, when we're talking about molar volume, I'm talking about any substance, doesn't necessarily need to be a gas. So again, molar volume is the volume occupied by 1 mole of a substance. For gases, when we're speaking about molar volume, we're talking about the gas being under the conditions of STP, or standard temperature and pressure. So assume from here on out, when we're talking about molar volume of a gas, we're talking about under the conditions of STP. So we can use the ideal gas law to determine that the molar volume of a gas is actually 22.4 liters. So let's try this out. Let's prove this to ourselves. We'll start by jotting down the ideal gas law, which is PV equals nRT. And let's list our variables. We've got P, V, N, R, and T. All right, and remember, molar volume of a gas, we're talking about under the conditions of STP, standard temperature and pressure. So we already know that our pressure is 1.00 atm. Our temperature is 273.15 K. We know our volume is Rx, that's what we're trying to calculate. R, because our pressure unit is atm, the R we're going to use is 0.08206 liters atm over mole K. And what about moles? Remember, the definition of the molar volume of anything is the volume occupied by 1 mole of a substance. 1 mole of a substance, which means our N is 1.00 mole. So let's plug in our numbers. We're going to have P, which is 1.00 atm, times V equals N times R times T. All right, let's cross out any units that we can. We can cross out moles and K. We'll multiply what's left over. So we have 1.00 atm X equals 22.41468.9 liters atm. And to get the X by itself, we need to divide both sides by 1.00 atm. So our ATMs cross out, and 22.41 blah 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 divided by 1 is 22.4 blah blah blah. So we have our answer. As far as sig figs, these are all All right, let's cross out any units that we can. We can cross out moles and we can cross out K. So now let's multiply everything that we can multiply. So we're going to end up with 1.00 ATMX equals 22.414689 liters ATM. And to get the x by itself, we're going to divide both sides by 1 ATM. And that crosses out our ATM units. Right, and 22.414 blah blah divided by 1 is 22.414689 liters. So we have our answer. As far as sig figs go, being that everything we used is a constant, we'll just pick by convention, we call this 22.4 liters. So again, using the ideal gas law, we can determine that the molar volume of a gas is indeed 22.4 liters. And this is true of any gas. The molar volume, the volume of 1 mole of any gas, is going to be 22.4 liters. There you go. All right, next up, manipulating the ideal gas law. So we have our ideal gas law, which is PV equals nRT. And then we have a few more equations we need to jot down. And the first one is density. Density equals mass over volume. And normally that's written as capital D for density equals small m for mass divided by capital V for volume. Then we have mole. Mole equals mass of the substance divided by the molar mass of the substance. Now think about this one for a minute, because it's something you should actually already know, even though it may not specifically be in your head. Think about when you're trying to figure out the mole of something. What do? You take the mass of that something and then calculate the molar mass from the periodic table, divide, and you're able to figure out the mole. So mole equals mass divided by molar mass. And the way that's symbolized is little n for number of moles equals little m for mass divided by capital M. And this is how we'll be symbolizing molar mass. Okay, so you need to be familiar with these equations. We've got the ideal gas law, PV equals nRT. We've got density equals mass divided by volume. And we have the number of moles equals the mass divided by the molar mass. All right, for the rest of the lecture, we are now going to try a couple practice problems so we can manipulate the ideal gas law, looking at the variables that we're given and what variable we're trying to figure out. I want to give you fair warning. These are kind of a pain, okay? But think of them as a puzzle. Every problem is going to be different. You just need to look at what you were given, look at what you're trying to figure out, look at the equations that you have. I guess it's all of these, right? Look at the equations that you have and figure out what you need to do. Okay, so take a deep breath and let's try this. So our first problem is calculate the density of nitrogen gas at 125 degrees Celsius and a pressure of 755 torr. So reading this question, it looks like we're only given one of each type of variable, right? We're not changing, the gas isn't changing, for example, from one pressure to another, or from one volume to the other, which means we're going to be using the ideal gas law, PV equals nRT. So let's list out those variables and see where we're at. So we've got P and V and N and R and T. So we know that the pressure is 755 torr. They don't say anything about volume, and they don't say anything about moles. We know our R is going to be 62.36 liters torr. Mole K, and our temperature is given at 125 C, but we have to use K, so we have 125 degrees Celsius plus 273.15, giving us 398.15 K. And then because we're adding, we need to look at places after the decimal. And 125 has no places after the decimal, which means our answer is going to have no places after the decimal. So our temperature is 398 K. All right, so we don't have anything written for volume or moles. Let's look back at our question. It's asking us to calculate the density. Density. Well, let's write the equation for density. Density equals mass over volume. Okay, well, that kind of helps us with the volume area. But what about our N? Well, let's write this. N, or number of moles, equals mass over molar. Whoops, that's not clear. Over molar mass. So now that we've got all of this written down, what do we do from here? Well, we've got N here and N here. So why don't we rewrite the equation, our ideal gas law, but with our N saying mass over molar mass. Let's try that. So we're going to end up with pressure times volume equals mass divided by molar mass times RT. Okay, remembering that what we really want is density, and density is mass over volume. Look here. In our new ideal gas law that we just wrote, we have mass and volume. So let's rearrange this so we end up with mass over volume, which is density, which is what we're looking for. Okay, so to go about doing that, let me first get the molar mass, multiply both sides by molar mass, which gets rid of the molar mass on the bottom, and let's divide both sides by volume. And then let's rewrite that so we can actually see it. We now have molar mass times pressure equals mass over volume, RT. And mass over volume is density. We're getting closer. So now we have molar mass times pressure equals density times RT. And now let's just divide both sides by RT. And yay, we finally did it. We've got density equals molar mass times pressure over RT. So we have now taken our ideal gas law and rearranged it to calculate for density. Okay, let me erase all of this so we can now plug and chug. All right, so our new ideal gas law equation is D equals density equals molar mass times pressure over R times temperature. Now we can solve for this. So we have X equals Oh, gosh, molar mass. Well, we've got to use the molar mass of nitrogen, which if you look on your periodic table, you will note that the molar mass of nitrogen is 14.007, but nitrogen is a diatomic, so there's two of them, which makes our molar mass 28.014 grams per mole, because molar mass is grams per 1 mole. Okay, so that's our M, and then our pressure is 755 torr. And that's all divided by R, which is 62.36 liters torr divided by mole K times our temperature, which is 398 K. We got a mess going on here, but we can at least cross out the K's. And let me write this a little bit neater here. We're now going to have X equals, and let's go ahead and multiply the top stuff. And I got 0.57 grams torr over mole over, multiplying the bottom, I got 2481.9.28 liters torr mole. All right, so now how do we deal with a fraction over a fraction? Well, if you remember, you can take the reciprocal of the bottom one and multiply. So I'm going to times mole over 2481.9.28 liters torr. So this stuff's now gone. And mole cross out. And torr cross out. So now we multiply and divide, giving us, change pin color, I've got a mess going on here, 0.086649169 grams per liter. Oh, we're getting close, and now we need to look at sig figs. We have 3, and don't care about that one, and 3. So our final answer, we're going to keep these 3. So our final answer, I'm completely out of room here, so I'll write it here. Density equals 0.0866 grams per liter. Woo! We did it. Hopefully you noticed that I just kept thinking about it and putting things together and putting things together. You just need to go slow. It's a puzzle. Don't try to memorize the steps because every problem's going to be different. It's also really, really helpful, even though it's messy, to write your units. It helps you keep track of what you're doing. All right, take a deep breath and we'll try another one. All right, this time we're going to be calculating molar mass of a gas. So our question is, the sample of a gas has a mass of 0.311 grams. Its volume is 2.225 liters at a temperature of 55 degrees Celsius and a pressure of 886 millimeters mercury. Find its molar mass. All righty, well, once again, we only have one of each type of variable, which means, again, we'll be using the ideal gas law. PV equals nRT. nRT. So let's write our variables. P, V, N, R, and T. All right, let's see what they gave us. They gave us mass. Not really sure what to do with that yet, so we'll leave that alone. We have a volume. Our volume is 0.225 liters. We have a temperature of 55 degrees Celsius. So again, we've got to turn that into K. So it's 55 degrees Celsius plus 273.15, giving us 328.15 K. And for sig figs, we're looking at units or digits after the decimal, and this one has none. So we know there's going to be none. So our temperature is 328 K. And let's see. Oh, we've got our pressure of 886 millimeters of mercury. And now we need to get our R. So R. R, we'll be using the 62.36 liters torr mole K. Now, why did I pick that one? Well, I picked that one, and I actually have to make a change here. If you remember, one ATM equals 760 millimeters of mercury, which equals 760 torr. So these two are basically the same. So I can use that R, but I will just change the unit here to millimeters of mercury. So it looks like our N is going to be our X, except it's asking us for its molar mass. Not only that, if you look here, they give us mass, so in theory we could figure out moles, except we don't know what gas it is. It just says a sample of gas. So somehow we have to put something in for N to somehow come up with molar mass. Well, let's write the formula for N. So we have moles equals mass over molar mass. Well, that'll work because we have a mass and we're trying to find our molar mass. So let's rewrite our ideal gas law equation, substituting mass over molar mass for N. So we'll have pressure, times volume equals, instead of N, we'll put mass over molar mass equals RT. And if we want to get our molar mass by itself, we can have molar mass. We can multiply both sides by molar mass and then divide both sides by pressure and volume. And that gives us a new equation of molar mass equals mass divided by pressure volume times RT. There you go. Now we can solve for molar mass. All right, let's start plugging things in. We've got, again, molar mass equals mass, which is here, 0.311 grams, divided by pressure, which is 886 millimeters of mercury times volume, which is 0.225 liters. Then we have times R, which is 62.36 millimeters of mercury, liters, mole K, times temperature, which is, I didn't leave much room, 328 K. All right, can we cross anything out here? Make this a little neater. We've got K, and that looks like about it at the moment. So let's go ahead and multiply the top area, giving us, I got 1.2188 grams, millimeters of mercury, liters over mole, divided by, let's multiply the bottom, giving us 199.35 millimeters of mercury and liters. And then we can multiply, to get this off the bottom, we can multiply by the reciprocal, giving us 1 over 199.35 millimeters mercury liters. So that's gone. Our liters cross out. Our millimeters of mercury cross out. And if we multiply and divide the rest, we end up with 31.909800, etc. Units that are left are grams per mole, which, yay, is the units for molarity. For molar mass. So now we just need to look at sig figs. So we have 3 and 3 and don't care, and 3, giving us 3. So final answer, 1.9 grams per mole. Woo, we did it. Okay, folks, I know this seems tricky, but honestly, with some practice, as long as you're calm, look at it as a puzzle, it's going to be fine. All right, that's it for today. Have a good one.